When we want to read back in from a file, the process starts off being very similar as what we saw writing to a file. And then it gets a little bit more complicated. But we're going to start with the simple part. So the simple part here comes in where we would just open a file to read. We already know how to deal with files. We saw that from before. We created them, we managed them, we have now opened them to be written to. And so, like writing a file, we use a helper, a little object, to be able to read the file in. Now there's a couple differences. When I'm running out to a file, that file doesn't have to exist. I can create it along the fly. When I read a file, obviously we want that file to exist. If the file's not found, you're going to get an error. Also, that file has to be in a format that we understand. We can read any file, but we're going to have to get some data in from that file and make sense of that data, where in the other sense we're just writing over the file or tacking on to the end. So we'll get to that second part later on, but let's talk about the helper we use to be able to read in the file. So one of the ones we can talk about is a Java file reader. There's actually a file IO that lets us do ones and zeros. The reader is the one that lets us get to text right away, and that's what we're going to be doing right now, is playing with text. And so it gives us access to the data. And there's a bunch of methods inside of there. You can see I can read an integer, which is actually supposed to be translated to a character, one character at a time, or I can read in some array of characters. I can buffer a number of them right away. Now, we don't work in characters in Java. That's not good. We want to work in strings. That's what we're used to using. That's the data type we're used to using. If you remember, in Java, a string is not just an array of characters. So we need to get a better feel for that. But you can, if you need to, work at one character at a time. This is an example of some code that would allow you to do that. So I have a file, and then I go through and I use a character array as a buffer. Now the character array is empty to start with, and we're going to start filling it with some characters. So when I go and read from the file, I use the file reader. While there's still files left out there, so when I do a read, it tells me the number of characters that it read, and while that's greater than 0, we're going to go in and we're going to write out that buffer. That's basically going to read, in this case, 10 characters at a time. It could be 100 characters at a time. It could be 1,000 characters at a time. It's whatever size we build the buffer as. And then at some point, it's going to read in less than 10 characters, the size of this, and might read an 8, and we'll print out that last buffer, and then the next iteration it'll stop. It'll be done. So the thing about that is, when we read it in, a file normally has lines. We're used to normally seeing 1 line, 2 line, 3 lines, 4 lines of a file. That's not how this reads it in. This reads it in as just text. Character, character, character. And one of those characters inside of there might be a new line character. And in Java, one of the ways of representing new line characters is a /n. So we could get the buffer, and we could keep reading the buffer, forever, like we saw up here. We get that. So read dot is the reader.read there. And then for that buffer, we could loop through each character looking for a new line character. And when I get a new line character, then I could do something like copying out the range of something, and again, this is complicated. It's not something I'm expecting you to work on at this point, just to see that there's a certain amount of complexity. And it's actually more complex than this because there's more than one new line character possible. It could be a /n, could be a /r, which is a character return, or the combination of the two, depending on the operating system you're working on. So there's some variability. You probably do whatever logic you're working with, but it's complicated. And so the file reader is only mildly useful. It does open the file for us. It does give us the ability to read data from it, but working in characters isn't super useful. As I said, we want to work in strings. We want to read one line at a time most of the time from a file. And so the file reader is there for those of you who are building applications that need to deal with it at a character level. Some files, lines don't mean anything. It's just a bunch of characters. And the fact that I put a character break instead of there, it's not important towards the data. And so what I really want to do is be able to read at the lowest level. But in order to work with something more interesting, we need to work with things like strings, and we want to do things like read a line at a time. And so we need higher level of data types. So we need to take those characters, like the example we just saw, and read them until I see a new line character and put that into a string. And we have more tools to help us do that. Those tools come in the form of filters. Now we've introduced the idea of filters, but let's get a little bit more formal into one of the types of filters, because it's really essential to understand them when reading in particular. So when we were writing, we took our data out of all the real world possibilities, the way we could represent data and represent it as nice, clean Java objects, and then spit those out by formatting them through whatever text formatting you decided to do. To read it back in, we have got to take all the chaos of what's out there. Even if we made the Java file, some fool user might have went and edited it by hand, and we've got to try and structure that into something nice and neat. So when we have the buffered readers, at the low level we saw the file reader, there's also the file input stream. The file input stream reads ones and zeros. And really the file reader probably makes use of the file input stream at some level behind the scenes. I don't know. That's Java's implementation. I'm not worried about it. But it does read in ones and zeros, turns them to characters. It takes the characters, and then we want to go to a higher level. And so a buffer is a specific type of filter that allows us to read from one data source and then collect data until it becomes something interesting and useful. Because everything has to be buffered in. It's got to be read in 5 characters at a time, 10 characters at a time, 100, like we saw. But a line in a file might be 100 characters or 1,000 characters, way bigger than the buffer. And so I keep reading in characters, I store them in the buffer, and I keep reading in characters, I store them in the buffer, I keep reading in characters, I store them in the buffer, until I decide I'm at a line, and then I give you that line back. And that's the idea behind a buffer. And so now we have our file, and we have our file reader, but I'm not going to read from the file reader. I'm going to take that file reader and deposit it into a buffered reader. So you can kind of think of it this way. I don't plug my computer directly into the wall because I'm concerned about energy spikes. So I plug it into a universal power supply that not only gives me battery backup, but also gives me protection against the spikes. So the buffer does that. It protects us from the data a little bit out there. It assumes a certain amount of formatting. And it buffers it up, just like my battery saves energy. My battery, my universal power supply, loads energy in, and then it delivers it to my computer. And if that energy runs out, I still have a little buffer left inside. That's, again, it's an analogy. Don't take it too literal inside of there. But that's the idea behind it. So now with the buffered reader, notice here, it gives me the line buffered reader dot read line. I can read one line from a file at a time. And that line comes back to me as a string. And as long as that string's not null, there's more lines in the file. And so I can do whatever I want to there. So if a line is blank, it's not null, it comes out as an empty string. Quote, quote, empty string. But until it returns back as null, there's stuff in the file, and it's going to return it as such. So this gives us much easier ways to access data. It allows us to go through and pull it in. So even if I'm reading numbers in from a file, I can take a text representation of a number, as you can see here, and I can parse that into a number and then be able to go read one lines at a time. So I can do number. Now this is a little bit of a preview of what we're going to see later on with formatted data and what. But I just want you to see, it really makes our data easy to access. So there's a lot of buffers out there. Java is more than just being able to read the buffers. Let's talk about a few of these really quick. We don't really need to use them here, but just so you're aware of them. So there's audio streams out there. A Java program can read in ones and zeros and store it as like if it's a MP3 or a WAV or whatever format is enabled for that. And there's actually a sound library that has some default formats and extensions that people have written as well. There's a pipe stream that allows us, this is actually a way to stream data between two threads in a program. That's for parallel processing. You'll learn more about that in the next class, just 351. And then we can maybe play with this, but it's not required, but just want to show you. This is an internal buffering technique inside of Java. It just stores the data internally. Similarly, a byte array string does the ability to take ones and zeros in and stores it in as arrays of bytes. And so this is like saying I have a network connection and I want to store the data coming in the network connection, but I'm too slow to process it. I want to be able to basically process it later on, but go ahead and read it in for now. It's a way of storing it internally into a Java program instead of writing it to a file. Then there's this thing called a sequenced input stream. Like let's say I have 5 files I want to read. I can just line them up one after the other and then say read this file, then this file, then this file, then this file. Again, I'm not entirely sure it's the most useful thing ever, but it's kind of interesting and it's available to you. So the next topic we're going to talk about here is delimiting the data. The data we're talking about still is very basic, so come back and then we're going to pick up here and we're going to talk about how we take that data in and do something interesting and useful with it.